Hello, this is Chemistry Central Science 11th edition. We are in the end of the chapter questions for chapter 3 on stoichiometry, and this is question number 19, and there is 5 parts to this, A, B, C, D, and E. All right, so they're asking 2 things of us. We're reviewing balancing equations from yesterday's lesson, and then whether they're combination, decomposition, combustion. Combination is when there's more than one thing on the left and it comes together into one thing in the right. Okay, so they're combining. Decomposition is the opposite. So there is one thing on the left and it breaks apart into multiple things on the right. Okay, that's decomposition. Combustion is specific. It's burning in air, specifically oxygen. So you're going to have something, usually a hydrocarbon, or an alcohol, some kind of an O, H, and C, CH usually, and then plus O2, that's oxygen gas, that's on the left, and then on the right you're always going to have water vapor and carbon dioxide. That's what you make when you burn anything. That's when you as long as it burns completely all the way through and doesn't leave leftovers. If it completely burns, you can burn methane gas, and the only thing you'll have left is carbon dioxide and water at the end, plus heat. All right. So first of all, what do we have here? We've got aluminum and chlorine. That's coming together on that's your reactants. But on the right, you're going to have aluminum chloride. Can you see that is a combination? So I'll say that first. This is a combination reaction, and now they're asking us to balance it. All right, so I start with aluminum. I have 1 on the left, 1 on the right. That's good. Chlorine on the left, I have 2, 3 on the right, so I need a multiple of 2 and 3. So I'll have a 3 on this side, a 2 on this side. That messes up my aluminum. I have 2 on the right. I have to come on the left and make 2. So 2, 3, 2 is number 1. Okay, so number B, let's see, what do we got? I see oxygen in the left. I see carbon dioxide in the water in the right. That is combustion. Okay, so combustion is burning. Something is burning in air. So in this case, it's the ethane, C2H4 is burning in the air. So let's balance this. We'll start with the carbon. The carbon, there's 2 on the left. I need 2 on the right, so I'm going to put a 2. Remember, you can only do coefficients. You cannot change the subscripts at all. All right, so what's next? I'll do hydrogens next. Okay, I've got 4 on the left, 2 on the right, so I'm going to put 2 there to make that 4. Now, I look over on the left and I see the oxygen is a double. That means everything on the right needs to be even. Otherwise, I'll never be able to get it done. So I look and I have O2 times something is always going to be even, and then this is 1, and if you have an odd number, it'll be odd. If you have an even number, it'll be even. But I have an even number, so that's cool. I think I can do something with that. So let's count the oxygens. 2 times 2 is 4. 5, 6. Okay, there's 6. So I need 2 times 3 is 6. And it's going to be 1 to 3 to 2 to 2. That'll be, that's here, 1 to 3 to 2 to 2. Okay, good. All right, lithium plus nitrogen gives me lithium nitride. All right, so I've got 3 lithiums on the right. Oh, first of all, what is it? I've got 2 things on the left coming together to make something on the right. It's combining. So this is a combination reaction. Okay. Probably shouldn't abbreviate combination since combustion's the same. So combination. Right. All right, so I've got 3 lithiums on the right. I need 3 lithiums on the left. I'm going to mess that up because I have 2 nitrogens on the left. That means I'm going to need 2 nitrogens on the right. That gives me 6 lithiums on the right, so that has to change to a 6. So that will give me 6 to 1 to 2 ratio. All right, what do we got? I have carbon dioxide being made, but I don't have water and I don't have oxygen. So this is not combustion, even though I'm getting a carbon dioxide. I've got one thing on the left, it's breaking apart into 2 things on the right. Okay, so this is decomposition. Now they're asking us to balance. I've got 1 lead on the left, 1 lead on the right, no problem. I've got 1 carbon on the left, 1 carbon on the right, that's great. I've got 3 and 1, 2, 3. It's already balanced. It's 1 to 1 to 1. I love those. Last one, I've got oxygen, carbon dioxide, and water. What is that? Okay, that's combustion. It'll always be the same. You're making carbon dioxide and water when you react something with oxygen, and reacting something with oxygen is called burning. That's what it is. When you have a chemical reaction with oxygen, that's called on fire. All right, so stay away. So let's do carbon first. I have 7 carbons on the left, so I'll start off with 7. Does that mean that it's going to be 7 at the end? Who knows? I may have to go back and forth and change a lot of it, but the only thing I know is I see what it is on the left and I try to make it even, and then I just go back and forth. All right, let's do hydrogens next. I usually do oxygens last. So I've got 8 hydrogens on the left. I need 8 on the right, so 2 times 4 is 8. Now, I like it because everything is even. I've got 4 oxygens, that's even. I've got 14 oxygens, that's even. I've got 1 oxygen, that's even, and our O2 and 1 O2. Okay, everything is even. So let's see how many we have. On the right, I've got 2 times 7, that's 14, plus 4 is 18. Okay, I have 18 oxygens there. I have 2, and I need 16. Okay, so 2 times what is 16? 8. Did you see how I did that? I started with this whole side, 18. I subtracted this so I could find out how many the oxygens I need. I needed 16, so 2 times what is 16? Okay, so this is going to be a 1 to 8 to 7 to 4 ratio. It's a combustion. Much faster than yesterday. Good job.